Hello everyone, today we start a new topic. This is NCEA 2.6 Algebra. This is an externally assessed module, so this is in the exam, so this is why I'm doing it first. It is external. You will be examined on this, so I'm getting this out first because I'm recording this in September, so it's just a couple of months until your exam. So we'll get the algebra out first with the calculus, and then we'll worry about the other internally assessed stuff later. You should be doing this in your class at the moment. So I'm going to start with quadratic equations. We've done a little bit of it in NCEA 1 algebra. We sort of step it up a level, but if you're not familiar with quadratic equations, probably good to go back and review last year's quadratic equations. They're really important, and they pop up constantly in algebra in this part of the exam. There will be questions, like quite a few questions in the algebra exam on quadratic equations. So quadratic equations, just to remind you, are equations in the form y equals ax squared plus bx plus c, often equals 0, where a, b, and c are real numbers. They're real. They're just numbers. They're the coefficients, the quadratic coefficients, and well, I guess the c isn't really a coefficient. It's a constant. Okay, so you should know that this produces a parabola. If a is a positive number, it will produce that looking parabola. If a is a negative number, it will look like that. C is, of course, the y-intercept. These are really important, even if it wasn't for the fact that you're being examined on them. They crop up all the time in physics. They're used quite a lot in statistics for modeling. They come up quite a lot in chemistry as well, engineering, and even modeling biological phenomena. Quadratic equations are really useful. So knowing your way around them is a big advantage if you're wanting to go further in maths or science or economics as well. All right, with that, we're going to start with factorising quadratic equations. So you should already be fairly familiar. So what that means is we're going to take it from sort of that form, and we're going to sort of x plus minus something and x plus minus something. So put it in brackets, in parentheses. The reason being is that you can then exploit that for other things. The most useful is to find the roots or the x-intercepts of a parabola. All right, let's do a really simple one. You should already be fairly familiar with, just to get you in the mood. So if we have x squared minus x minus 12. So first off, let's just ask, what is a, b, and c? Well, a is 1 because there's a 1 in front of that x. What's b? Well, b is -1 and c is -12. So it's going to be a parabola. 1 is greater than, a is greater than 0, so it's going to kind of look like that. All right, how do we do that? Well, if you remember, it's like a little algorithm. We find this number here. We want two numbers that multiply to give us -12 and add to give us -1. And work it through. It's going to be -4 and +3. And then we just take this and we put that in brackets, and that's that. So if we wanted to expand that bracket out, move that up a bit. If we wanted to expand that out, you could use FOIL, that one there, first and last out. One method that I always find really useful is a kind of a grid method.
So there's plus x and minus 4, which is this bracket, and then there is the plus x plus 3 for that bracket, and then we can kind of do it in a grid. So x times x is x squared, minus 4 times x is minus 4x, 3 times x is plus 3x, and 3 times negative 4 is negative 12, and then we can sort of collect up those terms. So x squared, 3x, minus 4x is minus 1x. That's that done, and then we have that. It's just a really quick way of doing it. It's a really good way later on if you get sort of bigger brackets of doing it. It's, if you want to use it, you don't have to use it, but it is a kind of a nifty, useful trick to have. Okay, what do we do though if the number that's in front of the x squared is not 1? Well, we panic. No, we don't really panic. We have a sort of a slightly different algorithm. I think we may have covered this briefly in year 1, but we really need to look at it in a bit more depth now. So let's say we want to factorize 3x squared minus 10x minus 8. And we have a problem now because we can't really say, well, what's two numbers for this one here that multiply to give us that and add to give us that, because there's this 3 that's complicating things out the front. So here's our little algorithm. First step is we take A times C, right? So in this case, A is going to be 3, C is going to be minus 8. So in this case, that's going to be negative 24. Okay, second step is we take this negative 24, so A times C, and cut that into B. And what I mean by that is find two numbers that multiply to give A times C and add to give B. Okay, so I'll do it in this case. So 3 times negative 8 is negative 24. So we want two numbers that multiply to give us not negative 8, but negative 24. And add to give us negative 10. So it's going to be negative 12 and positive 2. There's a trap here that you could kind of think it's 6 and 4, negative, but that multiplied together, that would give us positive 24. So it's negative 12 and positive 2. Okay. Third step is we use those numbers to sort of split up B. Can't think of another way of kind of describing it. So I'm going to rewrite this equation like this. 3x squared minus 12x plus 2x minus 8. Now just convince yourself that this equation here is the same as this equation here. The only thing is we've cut this negative 10x into negative 12x plus 2x, because negative 12 plus 2 is negative 10. That's all we've done. Okay, that makes our life a lot easier, because what I'm going to do, I'm going to kind of partition the equation like that. And I'm going to factorize this bit separately from this bit. And hopefully, well, we should get a common common term in parentheses and brackets. I'll show you what I mean by that. So the common term in this is going to be 3x. So I'm going to factor out the 3x. So 3x times what gives us 3x squared? Well, 3x times x is 3x squared. 3x times what gives us negative 12? Well, negative 4. Okay. And then I'm going to factor the second bit here. So what's the common factor here? Well, it's going to be plus 2 x minus 4. Now notice this is the same as this, which is good. That's a really, really good sign. Now we're going to kind of like factor out again. So x minus 4 is a common term in those. So we're going to collect up the terms outside and put them into their own bracket. And then we're going to sort of put that one that's already in brackets there. Okay. So we're going to factorize separately. And last one is we're going to combine brackets. Okay, so the good way the good way to learn this is to just do lots and lots of examples. So it's you may have some kind of dissonance in your head at the moment. You might be thinking, what on earth is going on? But this is really, really, really useful. And once you get the hang of it, you can generally be able to use it pretty effectively. It's really not that hard once you've done a few. Let's just keep going with a few more. Let's look at another one like that. This be really nasty. All right, that looks really, really tricky. It looks really, really tricky, but let's kind of stick to it. So a times, a is 12, b is plus 17. I'm going to make sure that I have my positives and negatives by putting plus and minus, and c is minus 5. Okay, a times c is 12 times negative 5, which is negative 60. So I want two numbers that multiply to give us negative 60 and add to give us positive 17. Well, the answer to that is going to be plus 20 and minus 3. And this stage here often takes quite a while to do because 60 has quite a lot of factors. So it's a matter of kind of sometimes running through them and kind of eliminating and finding the combination that works. There should be only one combination that works. All right, so far so good. What I'm going to do now is I'm going to rewrite this using these numbers instead of that. So that's going to be the equivalent of 12x squared plus 20x minus 3x. Now, just convince yourself that is the same as that. So all I've done is I've just kind of cut that 17 up into two pieces. All right, and then I'm going to partition it, and I'll make that line red. So I'm going to factorize this bit on the left first, and then that bit, and hopefully we'll have the same brackets. Now, what's the common term here? The common term here is actually 4x. Okay, so 4x times what gives us 12x squared? Well, it's 3x. 4x times what gives us 20x? Well, it's plus 5. And over here, we've got this, but we sort of a clue. We kind of want that. So what's the common factor here? Well, it's negative 1. Negative 1 times what gives us negative 3x? Well, negative 1 times 3x. and negative 1 times positive 5 gives us negative 5x. So we have the same bracket there, and then we're going to collect the terms outside the brackets and then insert the terms that are inside that bracket. So the 4x and the negative 1 go into that bracket, and we bring down this bracket here. So it's kind of like if I sort of said let 3x plus 5 be equal to a. Well, this is going to be 4x times a minus 1 times a. So these have a common factor, so we can factor out the a, and then we've got like that. So we're kind of like factoring inside of factoring. Okay, so then our final step, if we want to kind of go and test that, is let's expand out that bracket. So 4x minus 1, 3x plus 5. So 4x times 3x is 12x squared. Minus 1 times 3x is minus 3x. 4x times 5 is 20x. Negative 1 times 5 is negative 5. So that's going to be equal to 12x squared plus 17x minus 5, which is what we started with up here. This is the same. Okay. If you want me to do some extra ones, drop me a message in the comments, and I'll definitely do some for you. It's just a matter of doing lots and lots and lots of them. In class, your teacher probably got you to do lots and lots and lots of examples, because once you get the practice up, they do sort of become a lot easier later on. Let's do one more. So 3x squared minus 4x minus 4. That up. Okay, so first thing is there isn't a 1 in front of that the x squared, so I'm going to have our a times c. So a is 3, c is minus 4, so that's minus 12. So I want two numbers that multiply to give us minus 12 and add to give me negative 4. And just looking at it, it's going to be negative 6 and positive 2, isn't it? If you have a negative number there, by the way, one of them is probably always, well, probably it is always going to be negative and the other one's going to be positive. So that one is there, and let's split this up. Now here's a little trick. 6 is a multiple of 3, so I would put that one in first. The order doesn't matter. In fact, I'll do it again later with these the other way around, so you can see we do get the same answer. Squared there. So I'm going to factorize the left-hand side. So what's the common factor? It's going to be 3x. So 3x times x is 3x squared. 3x times negative 2 is equal to negative 6x. And here, what's the common factor? Well, it's going to be plus 2. X minus 2. Those are the same, so that's good. So 3x plus 2. X minus 2, and we're done. Just to test it out, 3x and plus 2 and x minus 2. 3x times x is 3x squared. 2 times x is 2x. Minus 2 times 3x is minus 6x. Minus 2 times positive 2 is minus 4. So collecting up 3x squared minus 4x minus 4, and that's the same as what we started with. So that's our answer. Okay, let's have a look at what would happen if we put the minus 6 and the 2 the other way around. So let's say instead of this, we rewrote it as this, plus 2x minus 6x is 4. Well, it's not really a big deal. So what's the common term between these first two here? Well, 3 and 2 are not common with each other, so x is actually going to be the only common thing they have in common, and this is going to be 3x plus 2. And this one here, what's the only thing they have in common? Negative 2 is the only thing they have in common, and it's going to be 3x plus 2, the same. So we can collect outside the brackets and inside the brackets, and we have the same, we get the same answer, the different order, but the same answer, because the order doesn't matter, multiplication. If you want me to do more videos on this, do let me know, and I will definitely do that. In fact, I might do some a bit later on anyway. I've got other stuff that we want to really get into with quadratics, but that's it for now for factorizing.